We're here at Intoco, Special Steels and Alloys, and they've challenged us, MTD CNC, alongside ZCC Cutting Tools and Hainbuch to collaborate in finding out the best way to cut alloy 718. This is a material that is often referred to as Inconel in our industry.
We've come here today because we've been tasked by Intoco to cut some really hard materials, and partners have been chosen to help us achieve the best results and cut this material in the most efficient way. So Intoco are going to choose a machine tool for us to cut this material on. We're going to be looking at the machine tool, the work holding and the cutting tools and the strategy, but not only that, the programming that's involved.
How does this material machine? It's such a difficult question to answer. It's a high nickel alloy, 60% nickel. Because of the nature of the composition of this material, each facet of machining, whether it be turning, milling, threading, boring, every one is slightly different to, say, conventional stainless steel or mild steels. So what we wanted to try and do was to dispel the negativity around machining this. It is a complex and difficult to machine product, but there are ways around it, and that's what we want to try and show.
The meeting went very well. The people that you brought in from ZCC and Hainbuch have come up with some good innovative ideas to help us machine this alloy 718.
The material's very hard to cut, so the cutting tool guys have got quite a problem there. Work holding needs to be very rigid and the part needs to be held firmly. A 3-jaw chuck I don't think is going to work in this instance, so I think we need one of our top plus collet chucks.
Yeah, so we obviously got to take the part away, the component away, and sort of engineer it to its optimum performance, making sure that we offer the correct solution for the customer.
I think that this is really illustrating what goes on at the beginning of a process. More often than not, we don't get to see the initial planning and all the potential problems that you need to overcome to get the solution.
The problems we come across when cutting the 718 alloy are the life cycle of the tooling that we're using cutting it.
Dave, this project is coming together now nicely. Now you've chosen the work holding.
What we've got here, G, is a 100mm top plus Hainbuch collet. And you can see from the top plus we've got the hex collet system. So totally sealed and ideal for hard metal turning to eliminate vibration. Well, the thing is, because you're clamping on a flat surface, it's totally sealed. You've got better rotational clamping force, and when the collet is pulled back into the chuck, it's totally sealed.
Now, we had some concerns over the spindle nose. Have they been addressed?
Yes, I think they have. You see, with a machine like this, a machine that we're not that familiar with, we're reliant on the machine tool company giving us the correct information. And that information is the spindle taper, and then the draw tube diameter and thread, and then the forward and reverse position. And the drawing, Gio, I've got here, this is what we've had from the machine tool company, and we've verified that that's correct.
Yeah, very tricky material to machine, but it's quite a common material we come across at ZCC Cutting Tools, and we feel that we have a good solution for this particular component.
And what strategy are we adopting? I know it's some of the new turning strategies.
Yeah, so we really want to showcase our tooling, so we decided to go with a trachoidal turning strategy with the deep groove, and also with the milling we've opted for a trachoidal strategy again. So we can take a shallow depth of cut but fast, and so we can save some cycle time, but also the load on the tool and the machine is less.
Yeah. And when you're programming within EdgeCAD, does it really matter what material it is, whether it's very hard material like today or whether it's very soft like aluminium?
So obviously that will make a big difference to our speeds and feeds and the cutting strategy we use, and this is why we're trying to implement trachoidal turning to hopefully make our tool life last longer and speed up the job. So I went on an EdgeCAM course a few months back in trying to better understand the coil turning, and between the two of us we were able to find a solution around it, and then we were just a bit concerned with how it would post from the cam system in relation to the machine. So with me going on the course, we had a bit more confidence in that, and we were able to trust that it would all post out correctly.
So the team is setting the machine now, but my question to you, Les, is how does this material machine?
It's one of the hardest questions to answer, and we get asked it an awful lot in the sales division. Special alloys, complex alloys such as 718 and 625 are by nature high nickel alloys, and the answer is almost impossible to give. It's not like machining mild steels or stainless steels. So each facet of machining, such as boring, turning, milling, tapping, is a different answer. So what we try to do is collaborate and with some special skills here, the work holding, the cutting tools, to try and demonstrate the complexities of machining this material and how you can overcome those complexities.
What industries is it that require this material, and what qualities has it got to relate to that particular industry?
Okay, in the material we're machining today, 718, it's an alloy, high nickel alloy. This serves really two principal industries. One is oil and gas, and the other one is aerospace. So what we're machining is the API version to NACE. It's for sour gas in the oil business, and it's slightly softer than the aerospace version, which is melted in a different route, heat treated in a different route, and comes out harder. It's about, to give you an example, what we're machining today is about 38 Rockwell C. The aerospace is about 42 to 44 Rockwell C. So it gets slightly tougher in the aerospace version of this material. But essentially the machining of is exactly the same, and that's really it.
Paul, Intoco have got a number of different machine tool models here, but they've picked the DMGMORI NT 4300. Now, this is a mill turn machine, but why did they choose this for this demo?
It's really perfect for this demonstration, and I think it's probably one of the biggest aspects of what we've seen here today. The foundation, I mean, we've talked about quality cutting tools, the right strategies, work holding, but of course what you need is the foundation where all that starts from. This, as it stands, is a true multitasking machine. What makes it a bit different is you've got what DMGMORI class as the DCG here, which is a direct centre of gravity, which we're talking now about the milling side, the milling head. This B-axis here is supported on like a horizontal machining centre construction. It's got a ball screw either side of the head, so and it's a box-in-box construction as well. So you're talking about probably the most rigid method of supporting a head that you could get. Now that's important because when you're doing challenging materials, you need to make sure you've got the strength, you've got not only the power, but you've got the ability and the stability surrounding all of those mechanics and mechanisms to be able to dampen out vibration. Having a flat bed on this machine as well with a that's very low also assists in getting rid of that vibration. And of course, it's not just the construction, it's what you've got in the two spindles here. Extremely powerful on the turning side, but very capable on the milling as well, with lots and lots of power.
So these machines are very much designed for hard materials and basically one machining process.
They are high value parts, one hit machining on very high value parts that you just cannot afford to scrap, parts that you cannot afford to make slowly, and parts that you need to make right. And something like this from DMGMORI is perfectly suited to that type of application.
So after overcoming all the obstacles to get to this stage, the machine is set and ready to go. Josh is just about to press go.
So Luke, very impressive. We've done the roughing. We're just about to start the finishing as well. How's it going so far?
Yeah, so far really happy. Tools work really well, and even with the roughing, the finish is looking really, really good. Yeah, so the trochoidal strategy is kind of similar to your milling, so small radial cuts trying to keep the load down on the tool. Yeah, and I think the benefits of doing this as well, we don't have to have different handed tooling and stuff like that, so we can reduce the cycle time and the load on the machines. Yeah, we're using our new YBS grade again with the U-drill. We've just drilled the component now and it's gone really well. And at 55 metres at 0.07 per rev, and yeah, you couldn't even hear it cutting.
How difficult is this in industry to try and achieve what you're doing here? How many companies would have this similar success to what we're actually seeing?
I don't think there's a lot of companies that actually go into machining Alloy 718 just for the simple fact that it is difficult. The tooling probably costs more than you would using other materials.
Geo, I think it's performed better than we thought it would. You know, the Hainbuch chuck with the ZCC tooling, it's just incredible. The roughing finish looks like a ground finish. It's incredible. So clearly there's no vibration, no chatter, and you know, the chuck and the cutting tips are performing just as we hoped they would.
Yeah, very impressed. The Workholding is exceptional. Got rid of any vibration cutting the Alloy 718. The tooling that we've run on it is cut extremely well compared to the way we would do a job like that before. And at the end of the day, we're thinking that at the end of the day, we've saved 30% cycle time compared to the old way that we would have cut the job.
So it's safe to say you've saved 30%, but we were running it quite conservatively.
Yeah.
You know, so would you say that there's more savings to be had?
I would say so. At the end of the day, we could try pushing the machine a bit further, the tooling, and save more time on the job.
So potentially, would you say it's realistic that we could save up to 50% cycle time?
I think so, yeah.
Yeah, I mean, the secret's not only down to the work holding, which is very, very rigid and actually pulls the part back onto an end stop, so it's held radially and axially solidly against the stop. It's down to the good tooling, it's good to a solid machine. Vibration is the key to parts like this. When you're cutting hard materials, it's important that the part is held solidly and you cut out all the vibration that actually ends up in the tool tip if you're not careful, and reduces tool life and obviously causes bad surface finish.
Yeah, when, as expected, Joe, we were very confident coming in today that for all the applications that were put together, the machine, the work holding and the tooling was going to produce a fantastic part.
Yeah, I think the thing people were most impressed with was A, the drilling, but more importantly, that trochoidal strategy.
Yeah, we wanted to sort of apply as many strategies as we could to this component to offer the best productivity. And by applying a trochoidal strategy through the groove section of the component, it's a minimum of 30% reduction in cycle times.
It's fair to say this is a one-off part. If you could save more time if needed.
Yeah, of course, we've had to be conservative. One take, one shot. So we went to the bottom book data, but made sure there was a stable process.
After a long day, we've come outside to get some fresh air and some well-deserved sunshine. Gio, how have you found the whole process?
I think it's been brilliant. I think it's been hopefully educational to our audience, and hopefully they've learned a different way to potentially machine some of this really tough material, the Alloy 718. So,
Are you planning to do any more like this?
I hope so. I think that dependent on how it's been received, it'd be something great to roll out. And, many thanks to Intoco, Hainbuch, ZCC, and all the partners that have been involved in making this possible.
Yeah, okay. And Intoco, of course, they supply special steels and alloys to the industry, and all of their products have full traceability and certification. So do get in touch with them and anyone else who took part in the video for more information.